Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video describes the difference between subjective and formal conclusions for a hypothesis test and provides some practice forming subjective conclusions. Let's get started. So to start off with, we're going to look at an example involving coin tosses. And the difference between subjective and formal conclusions for a hypothesis test is that with a subjective conclusion, you're simply looking at the data that's available. You're not calculating any test statistic or p-value, and you're just going to look at the data that's available and compare it with some standard that's relevant for the situation at hand. With a formal conclusion, you're going to be using the hypothesis test method that we've been discussing so far in previous mini lectures. So you're calculating a test statistic or a p-value, you're comparing that with the appropriate standard, and then deciding whether or not you're going to reject or fail to reject your null hypothesis. Here there is no null hypothesis when you're making a subjective conclusion, so you're just looking at the data at hand and seeing, is it all that different from whatever standard it is you're using for comparison. So here are the claims that a coin favors heads. Sample results show 11 heads among 20 tosses. Well, you would expect the coin to be fair, which means 50% of the time it should land heads. Here we've got 11 heads out of 20 tosses, so 11 divided by 20 is 55%. Don't be tempted to say, yeah, the coin's going to favor heads because it's greater than 50%. 55% is still in the same neighborhood as 50%. It's not that far away. It's still pretty close. So it doesn't appear that there's going to be, sufficient evidence to support this claim because you don't have substantially more heads than tails. And that's going to be the answer that we select here, answer option C. Again, don't get so caught in the details. If you're looking at something subjectively, there's a lot more wiggle room here than it is with the formal hypothesis testing method we've been discussing previously. So 11 out of 20 is not that far from 50%, and that's what we would expect from a fair coin. So we don't have sufficient evidence to support this claim. Let's look at another example involving mean income. So here the claim is that the mean income for entry-level engineers is more than $35,500. We have a recent survey of 240 entry-level engineers that shows a mean of $37,475. So here it gives us the standard that we're going to be using. It comes from the claim. It says that it's more than 35,500, and indeed, the mean value we get from a survey is more than 35,500. So here in this case, there does appear to be sufficient evidence to support the claim because the sample results are more than the claim. Again, comparing 37,475 to 35,500, I mean, the difference is almost $2,000. I don't know about you, but $2,000 is not pocket change to me. I'm guessing it's not to you either, especially if you're a starving student. That's some serious moolah. So, yeah, these two figures are not in the same neighborhood, and that's why we're going to select answer option A, because there does appear to be more in the evidence available than what is actually that actually is claimed to be. So obviously you can look at this, and the question that some students have when they look at this is, well, gee, if we can just look at the numbers, why are we even then going through the process of running a formal hypothesis test? But, one reason why we have the formal hypothesis test is that, that's just the increase from this one survey. Okay? Do we have that same increase in the population? And that's what we're really testing. We're using data from the sample to infer what data is there in the population without looking at everything that's there in the population. And that's why we have the hypothesis testing. We're trying to make inferences about the population with the information we have from the sample. Let's look at another example. So let's say we're going to yeah, we've looked at this sample, we've looked at this instance before. 20% of adults smoke is the claim, and there's a recent Gallup survey that says 21% of, 1,016 randomly selected adults are smoking. So what subjective conclusion can we make about this given claim? I'll give you a moment to, actually, you don't really need a moment. You just need a few seconds. You should be able to just look at this and say, yeah, one way or the other. So go ahead and do that. I'll give you a few seconds. Okay, well, I hope the answer you came up with was answer option A. Okay. This is where the subjective part comes in, right? Okay. So 21% is, not that far from 20%. But when you actually put the numbers out here, okay, you're talking about a difference of about 100 people. Okay. So the difference between 20% and 21% is actually about 100 people. And, there's a really good case to be made to say the difference is 100 people. Yeah, that's actually a significant difference. So here we're actually going to say there's sufficient evidence to support the claim because the sample results are more than the actual claim. Don't get caught up in looking at just the straight percentages and saying, oh, well, 21's in the same ballpark as 20. No, you got to actually calculate out the numbers. So this particular survey shows that there's more adults, but we could, who knows? We might get a survey that shows that there's less. How do we know what's what? Okay, well, that's why we have hypothesis testing to tell us what's what in the population. Let's look at one more example. So we're going to, again, look at this pulse rate example. The claim is that the mean pulse rate of adult females is 76 beats per minute or lower. We have a random sample of 40 adult females, and the mean pulse for that sample, 77.5 beats per minute. So what subjective conclusion can we make about this given claim? Again, I'll give you a few seconds. Well, here in this instance, you're going to want to select answer option C. There's not sufficient evidence to support the claim because sample results are more than the claim. So the sample results, you see, the 77.5 is greater than 76. Okay. However, the claim is that it's 76 or lower. So 77.5 is higher. So we don't have evidence to support the claim that it's lower. We have evidence to support the claim that it's higher. So we're going to say there's not sufficient evidence to support the claim because the sample results are more than the claim. And again, that's just this particular sample. For all we know, we could take a different sample and come up with a lower mean value that would actually support the claim. This is why we don't use subjective conclusions all that much. Which kind of makes me wonder, it's like, well, why is the author of your textbook making this part of your assignment? And the answer I get is, well, I don't know. Maybe he just likes messing with your mind. I can believe that with the way some of the questions are written, right? He's just trying to mess with your head. So that may be what's going on here. At any rate, just kind of learn how to do this, and then you just get through it, and then you just move on to the next big thing. And that's what we're doing here. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.